Good morning, everybody. What a beautiful morning in a beautiful city, Benghazi. I'm very honored and I am very proud to stand here today to talk to you. And I would like to welcome everyone here this morning. Thank you for coming in and thank you for the effort you put in for the travel. I hope you're enjoying your stay and I hope you'll enjoy the time you spent here at the conference. I would like to start by giving thanks to all these people who organized this conference for the incredible effort that they've made, the organizers, the steering committees, the scientific committees. I'd like to also thank the sponsors for this scientific and engineering event. I'd also like to thank the Libyan International Medical University in Benghazi, who is hosting this event. And I would especially like to thank the president of the university, Professor Muhammad Saad Mubarak. I also would like to thank the university vice president, Dr. Tawfiq Al-Tawil, the head of the Faculty of Information and Communication Technologies, who is the chairman of the ICEEIT 2020 conference. Let's start.
I'm going to start the talk today about the fifth generation communication. My name is Faheem Bukhatwa, and I'm a senior lecturer and a program director in Griffith College Dublin in Ireland. And today I'm talking, explaining what the 5G is, what the challenges are, and how does it compare to other generations, or the fourth generation and the previous generation, and the uses and applications, and maybe if there are any health risks, if there's some talk about the health risks. What is the fifth generation? And the fifth generation is a wireless communication system that started many years ago with the first phones. And the first telephones, they were analog, old telephone systems. They were not digital telephones, and they didn't have any computer operations or programs. And they started back in the 80s, and they used to be heavy in size. They probably used to carry a large battery with it, and had very little power other than making a phone call, the ordinary analog phone call. Then the newer telephones came out, and they called them the second generation. In the 90s, the second generation came out, and they were digital telephones that also only did telephone communications. But they were a bit smaller in size, lighter in weight. You could actually communicate with them. And remember the third generation, that they started having multimedia, the text, they had videos, they had images that you can send. And then finally we got the fourth generation, which is present now, the one we're using with all the apps, all the performance, reasonably high speed, and we have nice good videos and pictures. So the next progress is the natural progress, what they call now the fifth generation, and which has already actually started being implemented in many countries around the world. Especially this year, the last few months, the rate of acceleration in actual implementation has increased tremendously. The fifth generation and the fourth generation, this is just a quick image that shows the older fourth generation, where there's a mast, the mast that transmits the power to all the devices within a city. In a city divided into areas or cells, hence they call it a cellular phone. And the phone, as it moves from one area to another, it gets the power from one transmitter to the next transmitter. With the newer and the fifth generation communication, the mobile phones and the transmitters, there'll be even more transmitters inside the city. So instead of, longer distances, there'll be at shorter distances, more transmitters, and more phones will be connected and communicating through the local transmitters, and they pass their signals to the larger transmitters, and they keep going around, signals move from one place to another. And hence, that's the reason why we're going to be hopefully having clearer signals, and more signals or more devices can be connected to individual within a certain area. And the fourth generation language, or the fourth generation devices, they have a range of maybe 1 gigabyte per second per square kilometer. While the fifth generation, as it starts initially, it gets immediately to 10 gigabyte bit per second, and with the increase of, or the implementation of more devices or more transmission techniques, it will go up to 100 gigabits, and then it's expected to reach the 1 terabit. That's 1,000 million bits per second. So just that alone shows the new technology will have maybe 1,000 times extra capacity than the existing technologies. The fifth generation, just compared to the fourth generation, it will have a magnitude of maybe 1,000 times more mobile data volumes and 10 to 100 times numbers of extra devices that can be connected within 1 square kilometer, or even in total. They reckon they'll be able maybe to connect 7 billion devices around the world, worldwide, eventually when it's fully implemented. And that's a lot more than, at the moment, than that is being used at all. Also, fifth generation will have a lot less latency. That's the delay. It will have very little or very negligible delay, close to a zero, almost zero delay in transmitting signals. And the battery life is 10 times longer than existing devices. So latency will be reduced to 1 millisecond or less, under 1 millisecond. The throughput is 10 gigabyte per connection for each individual mobile phone. The connections will increase to about 1 million devices as the capacity for individual square kilometer. So the potential is tremendous. The mobility, with the older phones, again, there's a maximum. If you travel in a train, you couldn't use a mobile phone if the train reaches 350 kilometers an hour, which luckily we don't have those trains in Libya, so that will not affect the transmission. But in the newer generation, it will go up to 500 kilometers without the interference or the effect on the communication. So it increased the maximum speed that will start interfering with the communication. And it's using also 5G allows the use of newer kind of techniques in slicing networks, which increases also the performance and improves the performance, increases the capacity. One of the requirements that was, maybe I'll just go back and just go through this quickly in Arabic. The fifth generation, the standards organization, in their requirements, they specified that the new fifth generation should be backdated, or it will accept and operate the fourth generation mobile phones. Fifth generation, it uses different frequencies to the existing fourth generation, and they've used a lot of available radio frequencies, and there's a lot more frequencies that may eventually be used. And there's a new architecture in the way networks are installed, masts and transmitters and receivers are installed, and the availability of movement and mobility. The newer fifth generation language is a system that's known as multi-input and multi-output, and in fact they've used a massive multi-input and multi-output. The newer techniques in transmission beams are now the older beams you just transmit, broadcast, to cover a general area. Now with the newer systems, they've introduced transmission areas that can actually direct the signal to a certain point, and there will be vertical signals that they can actually send multiple signals to different levels in a particular building, and they'll also be able to communicate with cars at certain altitudes, and also they have scanning if the network does not know where the device is, the mobile device, it can do a scan until it localizes or identifies the location of the mobile, and then just concentrate that signal with a particular device. This has a lot of implications onto the power consumption. The more you transmit, then obviously the more power, electric power is consumed. So the newer techniques will reduce the power consumption definitely in the newer signals, because if they're more or less, they're more intelligent transmitting devices that they can identify a particular device and concentrate, and then they also can identify the power of that signal that's coming from that device, and they can accordingly adjust their power as well, so there's no need to transmit a powerful signal when they know the device is nearby and it can receive the signal at a much slower or weaker rate. And that improves, reduces the transmission power consumed. One of the reasons why they were able to be able to transmit a lot more data, could get a lot more mobile phones and devices, is through the ability to be able to transmit more signals. And the main reason, the main factor in the amount of data you can transmit is the frequency of the signals you can transmit at. And previously, all the previous generations, telephone companies were allocated much lower frequencies than they could use. Now, they have been internationally, there have been a lot of agreements between different organizations around the world and authorities, because you need a license to have a certain rate or level of use for a particular frequency range. So they started allocating to communication companies or to the technology of 5G, they allocated them the higher ranges of the radio frequencies. So now they started initially with the range of around 700 million hertz or megahertz, and then a number of international organizations, they're trying to get a general agreement so there will be a total consensus on all the equipment being manufactured in different countries in the world, that they will use the same range and the same power by whatever country you go to. So now the latest range they're talking about, they've already approved the 3.6 gigahertz, and they're actually thinking of going to the 26 gigahertz, which will even increase further by the time it is implemented. The total amount of data that can be transmitted, or the total number of devices that can be connected at the same time. So devices requirements, you make the newer devices, they need to be able to transmit on a millimeter kind of wavelength. So those newer frequency waves, the length of the wave is measured in millimeters. And that's hence the reason that now they have a lot more frequencies that they can transmit. The devices are slightly more complex, and they have the ability to transmit multiple signals and steer multiple signals, and varying the shape of the signals as well, from vertical to common to group signaling, and also they have advanced modeling techniques. But they're already, most of these problems have been sorted out, and newer devices have been rolled out. The networks itself, it must be able to transmit millimeter wave frequencies. They must have the newer complex antennas, or maybe intelligent antennas, that they can isolate different signals, they can concentrate on a particular device, or transmit multiple signals and receive multiple signals simultaneously, because in the past it was not possible to do that at the same frequency. If you transmit some frequency, and you try to receive a signal on the same frequency, a lot of noise occurs and it wasn't possible. Now they've been able to filter that out and improve that. So the same transmitter can transmit a signal at a certain frequency, and also if a signal comes in at the same frequency, it can isolate the one it sent and just receive the incoming signal, even though it's come at the same frequency. So also there's, as well as the multiple input, multiple output beam, also a beam steering. Then now they can change the signal direction and isolate or identify a particular source or target. Also the power averaging of the electromagnetic force that's generated by those signals. This should be lower according to the standardization, and the advanced modeling techniques are all implemented in those networks. The newer devices, they'll be installed, and there'll be more of them, a lot more of those devices, transmitters and receivers, in every possibly street, in every city, in order to be able to use this newer technology. But those devices, they'll be transmitting a lot more signals, but at a much lower power than the older transmitters. Because the older transmitters, they have longer distance to cover, so the power of the signal has to be quite powerful enough to reach the range, a mobile phone sitting on the range, or else you go outside the range. But with the newer ones, because they physically are limited, they cannot transmit a high frequency signal for a long distance. There is a maximum limit. And this limit actually is measured in meters. It's not a very long distance. So once it's, and therefore they'll be needing a lot more transmitters that transmit within the city, a lot more than there used to be.